Stars are born in vast clouds of gas and dust scattered throughout the universe. These clouds are called nebulae. Nebulae are like giant cosmic nurseries. They contain the raw materials needed to create stars. These materials are mostly hydrogen and helium, the two lightest elements. Gravity plays a crucial role in star formation. It pulls the gas and dust in a nebula together. As more and more material clumps together, the cloud's center heats up. This hot, dense core is called a protostar. It's not a star yet, but it's on its way. The protostar continues to gather material from the surrounding nebula. It grows larger and hotter over millions of years. Eventually, the temperature and pressure at the core become so intense that nuclear fusion begins. Nuclear fusion is the process where hydrogen atoms fuse to form helium, releasing tremendous energy. This energy makes the star shine. The moment fusion begins marks the birth of a star. Our sun, like all stars, was born in a nebula billions of years ago. Once a star ignites nuclear fusion, it enters a long, stable period called the main sequence. This is the prime of a star's life, where it spends most of its time. Our sun is currently in its main sequence stage. During this stage, a star exists in a state of equilibrium. The outward pressure from nuclear fusion balances the inward pull of gravity. This balance keeps the star stable. The mass of a star determines its lifespan on the main sequence. Massive stars burn their fuel much faster than smaller stars. They live fast and die young, exhausting their fuel in just millions of years. Smaller stars, like our sun, are more frugal. They burn their fuel slowly and can live for billions, even trillions of years. Eventually, even the most massive stars run out of hydrogen fuel in their cores. When this happens, the star begins to change dramatically. With hydrogen exhausted, the core contracts under its own gravity. This causes the core to heat up even further. This heat triggers fusion in the outer layers of the star, causing it to expand enormously. The star swells up to hundreds of times its original size, becoming a red giant. Red giants are cooler than main sequence stars, giving them a reddish appearance. During the red giant phase, stars fuse helium into heavier elements like carbon and oxygen. This process is essential for creating the building blocks of planets and even life itself. Section 4, Stellar Demise, Supernovae, Neutron Stars and Black Holes. The fate of a star depends on its mass. Smaller stars, like our sun, eventually shed their outer layers into space. This creates a beautiful expanding cloud of gas called a planetary nebula. The core of the star remains as a dense, hot object called a white dwarf. White dwarfs slowly cool down over trillions of years. Massive stars have a much more dramatic end. They continue fusing heavier elements in their cores until they reach iron. Iron fusion doesn't release energy, instead, it consumes it. This causes the core to collapse rapidly. The collapse triggers a shock wave that rips the star apart in a colossal explosion called a supernova. Supernovae are among the most energetic events in the universe. They can briefly outshine entire galaxies. The remnants of a supernova can form two incredibly dense objects, neutron stars and black holes. Neutron stars are the collapsed cores of massive stars. They are so dense that a teaspoon of neutron star material would weigh billions of tons on Earth. Black holes are even stranger. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are formed when the core of a massive star collapses to an infinitely small point. Section 5. Our Sun's Fate. Our Sun is not massive enough to go supernova. In about 5 billion years, it will exhaust its hydrogen fuel and begin to expand into a red giant. It will engulf the inner planets, including Earth. Eventually, the Sun will shed its outer layers, forming a planetary nebula. The core will remain as a white dwarf, slowly cooling down over eons. The life cycle of stars is a story of birth, life, death, and rebirth. The materials from dying stars enrich the interstellar medium, providing the building blocks for new stars and planets. The atoms in our bodies were once forged in the hearts of stars. We are all made of star stuff.